ferrous sulfate solution is mixed with ammonium sulfate solution in 1:1 molar ratio. Okay, it gives the test of ferrous ions, fine, but copper sulfate solution mixed with aqueous ammonia in 1:4 molar ratio does not give test of copper ion. Okay, explain. So, this is actually the difference between double salts and the complex salts. What happens? What happens is that when ferrous sulfate and ammonium sulfate are mixed in the ratio 1:1, they actually, if you evaporate water, you can get actually a single crystal of a double salt. And what is that salt? That is ferrous ammonium sulfate, FeSO4 dot NH4 whole twice SO4 dot 6H2O. This is what you would obtain. What is this? This is a double salt. Anything unique about double salt? Yes, many things unique about double salt. If you have a double salt here, double salt retains the entities, retains the properties of its individual salts. That means whatever were the tests given by ferrous ions or sulfate ions or ammonium ions separately, this double salt single-handedly would be able to give you test for each of these ions separately. It will not change, it will not show you new properties, and that is why it is called double salt. So what is a double salt? If two or more simple salts can crystallize together, and if they can form a single crystal containing both the salts, that means you have ferrous ions, ammonium ions as well as sulfate ions in a single crystal structure. That is called double salt, and the important property of double salt is that the individual property of ions remain unchanged in case there is a formation of double salt. Perfect. Let's look at the second half. If copper sulfate is mixed with ammonia in 1:4 ratio, you know what happens? Actually, something very interesting happens. You get tetramine copper sulfate. Now, this is actually a complex salt. Oh my God, what has happened? Copper ion has actually formed a complex with not 1, not 2, not 3, but actually 4 ammonia ions. And now this is the entire cationic entity. Is it copper ion anymore? No. Copper ions are now bonded with 4 different ammonia molecules. So it is a tetramine copper cation. The nature of cation has changed. It is a new cation. It is a complex cation. That is why we call it a coordination compound or a complex entity. And this definitely has properties different from copper ions as well as ammonia molecules. It has a new entity which has altogether new properties which may or may not be common with copper ions or ammonia ions, ammonia molecules individually. And that is why it is called a coordination compound or a complex compound. Complex compounds always have new and different properties from their individual constituents. That is the reason why this difference exists.